In this, we will understand about how do we determine the confidence limits for a population correlation coefficient. So if we want 95% confidence limits for rho is nothing but the population correlation coefficient, then it will be R plus or minus Tn minus 2 of 0.025 multiplied by standard error of R. Standard error of R is nothing but 1 minus R square divided by root of n. This n minus 2 is the degrees of freedom, and we need to refer to the T tables for a one-tailed test. 95% confidence level in the sense 5% significance level, and that is meant for a two-tailed test. So since we need to refer to the tables, which is a one-tailed test, we will be taking half of 5%, which is 2.5%. That is why it is 0.025. Similarly, 99% confidence limits for rho are R plus or minus Tn minus 2 degrees of freedom at 0.5%, 0.5% level of significance times standard error of R. That remains as it is the same. Now let us do some numericals for this. A correlation coefficient of 0.42 is derived from a random sample of 27 pairs of observations. What are the 95% and 99% confidence limits for the correlation coefficient in the population? So here, the sample correlation coefficient R is given as 0.42 and sample size is given as 27, which means our degrees of freedom is n minus 2, which is 27 minus 2, and that is 25. Now, we are supposed to determine 95% confidence limits. 95% confidence limits are R plus or minus T table value for n minus 2 degrees of freedom. Since this is 95%, we will consider 2.5% level of significance for a one-tailed, which means 0.025 multiplied by standard error of sample correlation coefficient, and that is 0.42 plus or minus. T table value for this will be 2.06. T table value for 25 degrees of freedom at 0.025 level of significance is 2.06 multiplied by standard error, which is 1 minus of R square. R square is 0.42 the square divided by square root of 27. So if we evaluate this, we get 0.42 plus or minus. Numerator will work out to 1.6966. Denominator is 5.196. That will give us 0.42 plus or minus 0.33. Therefore, 95% confidence limits are 0.42 minus 0.33, which will give us 0.09, lower limit, and then 0.42 plus 0.33, which will give us 0.75, that is the upper limit. So in between these two, the population correlation coefficient will lie, which means that our population correlation coefficient rho lies between these two limits. That is the solution for this. Let us move on to the another question. A correlation coefficient of 0.2 is derived from a random sample of 625 pairs, means R is 0.2, N is 625, which means our degrees of freedom, which is N minus of 2, and that will be 625 minus 2, so 623 will be the degrees of freedom. Now again, 95% confidence limits and 99% confidence limits. Oh, sorry, here we didn't do 99%. Let me do that also. This is 95%. Now, let us do 99% confidence limits are R plus or minus T n minus 2 of 0.5%, which means 0.005 for a one-tailed test multiplied by standard error of R. So that will be equal to 0.42 plus or minus, and for 27, I'm sorry, for for 25 degrees of freedom, 0.005 level of significance, the t table value will be 2.787 multiplied by 1 minus of 0.42 the square divided by root of 27. If we evaluate this, we will get 0.42 plus or minus 0.44. That means our 99% confidence limits are lower limit will be 0.42 minus 0.44, which will give us negative 0.02. Upper limit 0.42 plus 0.44 will get 0.86. This implies that our population correlation coefficient lies between 0.02 to 0.86. So that will be the solution for the first question. Let us move on again to the second question. Okay, now 95% confidence limits are plus or minus. Here, this degrees of freedom is exceeding 120. So we'll be considering the normal table value for a two-tailed test, which is 1.96. Standard error of R. That will give us 0.2 plus or minus 1.96 times 1 minus of 0.2 the square divided by square root of 623. If we evaluate, we will get 0.2 plus or minus. This entire thing will give us 0.075. So therefore, this confidence limits, 95% confidence limits, are 0.2 minus 0.05. That will give us 0.125 lower limit. Upper limit will be 0.275. That means our rho lies between 0.125 to 0. That is population correlation coefficient lies between these two values. That is 95%. Now let us do 99% confidence. 99% confidence limits are same R 0.2 plus or minus. 99% means we will directly take, because the degrees of freedom is 623, we will directly take the normal set value, which is 2.58 times 1 minus of 0.2, the square divided by square root of 623. That will give you 0.2 plus or minus 0.099. So therefore, 99% confidence limits are 0.2 minus 0.099. That will give us 0.101. And if we add, it is 0.299. This indicates that our rho value, that is population correlation coefficient, lies between 0.101 to 0.299. So that will be the solution for this particular question.